Hello students. In today's world, artificial intelligence, machine learning, data science and big data, these are the buzzing words, right? So the artificial intelligence has changed the entire face and pace of the world. Now, I'll try to explain what is the difference between artificial intelligence and machine learning, as well as I will try to demark artificial intelligence, machine learning, deep learning, and at that juncture, what is the role of data science and why data science and data is important to us, and what is the difference between classical programming approach and machine learning programming approach. Okay, let me begin with a small story, that is a tale of man and machine. In 1996, IBM's Deep Blue machine, the name of this machine is Deep Blue. This machine defeated the world's legendary chess champion Garry Kasparov successively 2 times. In 1996 as well as in 1997, IBM's Deep Blue defeated the world's best chess champion, Garry Kasparov. So this is a big breakthrough for AI scientists. So the machine defeating a man is really a breakthrough, and after that, in less than 25 years, this has completely changed the pace of the world, and now this AI is in your pockets. The artificial intelligence is in your mobile phones, right? Just in less than 25 years, right? Today's trending thing is artificial intelligence. AI is everywhere, and these are the world's legendary or tech giants: Google, Facebook, Apple, Amazon, Microsoft and Twitter. And any product from these companies can be considered as an AI product, right? Any product from these tech companies. ChatGPT, of course, ChatGPT is from OpenAI, but it is a subsidiary of Microsoft, right? Just as an example, I mentioned that even Google also has its own ChatGPT kind of platform, that is Gemini, right? So any product that is coming out from these tech giants will be considered as an artificial intelligence application. And for example, you take your Google Maps app. Can you imagine your day without Google Maps? How much time it will take to reach the destination, and what will be the shortest path to reach my friend's home? Just to understand this and to know this information, we are using that. The using that app has become a normal to us, right? So not only that, in the weather prediction app, for example, you take the weather prediction widget that is there in your Android phones. It tells you what will be the temperature and what will be the wind speed, whether it is going to rain in the next 24 hours or not, right? So this is the power of artificial intelligence, and in each and every artificial intelligence application, at some level, at some extent, the underlying technique that is used will be a machine learning algorithm. Most of the times the approach will be machine learning approach, and it is not a classical programming approach or a rule based approach. Of course, sometimes the rule based approach can also be used for artificial intelligence, but now machine learning is the most widely used algorithmic approach in artificial intelligence AI applications. Okay, this is Amazon's Echo. Amazon's Echo is a virtual assistant system. You know that you can instruct you can give some voice instructions to this device, and your instruction will be executed by this device, right? So the other devices like washing machines or your audio players or televisions, they can be connected to, they can be linked to this device through Wi-Fi, and you can control switches, your lights as well as fans in the house with through this device, right? Right. It is basically depending on the speech recognition algorithm. The speech recognition algorithm is combined with some Google search engine to to obtain some results, the desired results, or else it will be combined with the Wi-Fi. So it is all about networking, right? Next, this is a Google Lexus car. Lexus is a luxury car from the brand Toyota, and this is an autonomous driving vehicle. We may think of it as a next generation AI system. Most probably in another 10 or 15 years, even in India also, we can expect this kind of autonomous driving units, right? Next, I'll give you another popular example, that is a Netflix recommendation system. And you know what is the role, what is the job of a Netflix recommendation system? More or less, in all the OTT platforms we have this kind of, you can experience, you might have experienced the recommendations, personalized or customized recommendations based on your watch history. What kind of content you have consumed in past, based on that you will get the certain kind of recommendations. Let us say you have watched 5 or 6 different kinds of shows related to politics, then immediately you will get a few recommendations that is related to politics. You are going through, you have consumed some content that is related to history, then again that kind of recommendations will be given to you, and these are totally personalized recommendations. Your recommendations are different from my recommendations, and these recommendations are completely the content that you have consumed, right? So this, if you look at these 3 tasks that I have mentioned, to perform these tasks some human cognition as well as some human intelligence is needed. Even to play chess, the games like chess, a lot of human intelligence is required. But how a machine is able to do those kinds of tasks, right? So that is what I have mentioned. This is a kind of breakthrough. A man that is also the person with the highest IQ levels in the world has been defeated by a machine. So that result, that after in less than 20 or 25 years, it has this is the transformation that we got. Everything now in our pockets, in our surroundings, the AI is completely there now in our surroundings. And remember, AI is not to replace the human intelligence. AI is there to assist the human intelligence. There is a clear-cut difference, right? AI is not to replace the human intelligence. There is no substitute for human intelligence. But you can take the assistance, or you can take the support from artificial intelligence, right? And if you observe these 3 examples that I have mentioned here, in all these 3 examples, human cognition as well as intelligence is involved to perform the task. For example, to drive a car, human intelligence is required, right? You and I can drive a car, but not a cat or a dog, right? The intelligence levels of animals is not sufficient to drive a car, right? But a machine is able to do that task. Similarly, if you look at this recommender system. Recommender systems, just to recommend something to a person, you have to observe that person. What is his behavior, and what is the nature of that person, and what is the thought process of that person. All those things are to be captured to before suggest something to that person, right? So what you have consumed in past, based on that, the mission itself is able to tell, okay, this may suit for you, this is the suitable content for you. It is giving such kind of suggestions means this is also a kind of this is also a task where human intelligence is required, right? So now with these three examples, how can we define artificial intelligence? See, this is any method that tries to replicate the results of some aspects of human cognition. So, artificial intelligence is a method that tries to replicate the result of some aspects of human cognition. Human cognition is as an entity, it is very big. A mission that is trying to replicate some aspect of human cognition. The entire aspect of human cognition cannot be captured by one single mission. This is capturing only the driving aspect of human cognition. This is capturing only the voice recognition and following the instructions. Who can recognize my voice? You can recognize my voice, right? And you can listen to me and you can follow me, whatever I am telling, right? So, similarly, who can suggest, who can give some kind of suggestions? More or less, a human being. This is just a part of that human cognition. This system is, it can do only, it can recommend only something, but this system cannot drive a car. Did you understand the point? But being a human being, I can recommend something to a person. Okay, this movie is good, you go and watch. I can recommend that to you. And if I want, I can drop you at your college by driving the car. And I can follow your instructions. If you ask me to switch on my washing machine, I can go and do that. So that is, to do that, I have the intelligence to perform this task. I have intelligence. I'm using my intelligence. I'm understanding your instruction and I'm following your instruction. Right? But here, whatever the system, AI system that I am defining, that can take only a certain portion of that human cognition. Right? One part is related to driving a car. So, an autonomous driving vehicle unit will take only that aspect of human cognition and it tries to replicate that aspect. So, any method that tries to replicate some aspects of human cognition is AI. And what exactly it is replicating? Is it mimicking or is it exactly replicating my thought process? No. Basically, what it tries to replicate is only the result of the task. It cannot replicate the thought process behind the human cognition. Okay, the way how your brain functions to do a task, the way how your intelligence works to perform a task, that cannot be captured by your AI system, remember. Okay, your AI system, you are driving the car, your AI system is also driving the car. The end goal is to reach the destination, right? You are playing the game of chess, as well as the mission will also play the game. The end goal is winning that game for you as well as to the mission. So the end result is important. The way how you are thinking, that is not required for this mission, for an AI system. Actually, there is another science that is called ANI, artificial natural intelligence, in which neuroscience is also involved. That is, ANI is it tries to mimic the human thought process, but not AI. Okay, AI has its own methodology, has its own approach to solve a problem. While driving the car to reach the destination, it has its own methodology. Let us say, while driving the car, suddenly a person is coming, an obstacle is coming on the way, then immediately you will apply the brake. The machine will also apply the brake. But what made you to apply the brake? So, what thought process behind that task? Is the thought process cannot be imitated by the machine learning algorithm. Your machine learning algorithm has its own approach to apply the brake. So the paths are different, but the result is the end goal is same. Similarly, while playing the game, chess kind like game, while taking a step, what made you to make that move? That cannot be captured by your AI machine, right? It will also take a move, but it has its own mathematical computations to make that move. That mathematical computations will not match with your intelligence, what worked behind making that move. Got it? So this is the basic artificial intelligence definition. Okay, I hope you got the idea what is artificial intelligence. Next, what do you mean by machine learning? In today's world, more or less in every application, AI application, the underlying implementation technique will be some machine learning algorithm. Of course, there will be some rule-based AI systems, but whatever we are using in our day-to-day life, in majority of those AI systems, machine learning will be used. There is a convenience with machine learning. So, what is machine learning? That I will try to give a sense of it. And for example, if you take this recommender system, in recommender systems, we will use a kind of unsupervised machine learning algorithm called clustering. Clustering will be used in recommender systems. What is the basic definition of machine learning? And here I'll try to give some informal definition. The formal definition or contextual definition of machine learning is a little bit different from what I am telling here. This is a field of study that gives the computers or the machines or systems, that gives the systems the ability to learn without being explicitly programmed. In machine learning, no explicit programming is required. Whereas in rule-based programming, what is rule-based programming? Your classical programming methodologies like C programming, Java programming, etc. In those programming approaches, there will be a set of rules. Those set of rules are converted into an algorithm, and those algorithm is converted into a program, right? But here, no such explicit programming is required. The machine is able to learn by itself, right? Like human beings. Right. So, based on that, machine learning algorithms are the programs that perform better with experience. Got the idea? As experience grow, that algorithm has to perform better. That is the basic idea. Any algorithm which behaves in such a manner is considered as a machine learning algorithm. Yes, humans can do that, but machines really can do that. For example, you take a calculator. I have a calculator, and that calculator is able to do only 3-digit multiplications. I'm using that calculator which is able to do 3-digit number multiplications from past 2 years, can I use it to perform 4-digit or 5-digit multiplication after two years? It is just a dumb machine. It is a rule-based machine. Right? So there is a limitation and it cannot do anything beyond that limitation. On the other hand, you consider a human being, a person who is doing multiplications, 3-digit multiplications from past 2 years as a part of his work. Now, if I call that person and if I ask him to try a 4-digit multiplication, he'll apply his cognition and his intelligence to solve that problem. What do you mean by that? He learned with experience. If a machine also behaves in the same way, that is called machine learning. The algorithm which is able to perform like that, which is able to show that kind of behavior, is considered as a machine learning algorithm. And these are the implementation techniques behind AI apps, artificial intelligence applications that are there in your mobile phones or in your tabs or in as well as in day-to-day electronic gadgets, right, that we are using. So this is the basic understanding of machine learning. Here I have two images, and by looking at those two images you can tell the first one is cat and the second one is dog. Let us say I'm showing this image to a 6 months old baby. I'm showing these two images to a 6 months old small baby. Can that baby distinguish which one is cat and which one is dog? No. He is too small to distinguish which one is cat and which one is a dog. Now, after 1.5 years, to the same kid, that means after 1.5 years means almost at an age of 2 years, to the same kid, I am showing the two images. Now, he is able to, that kid is able to at least point out which one is cat and which one is dog. Right? Again, after 1 more year, now that kid is at an age of 3 years. Now I am showing again the same set of images, cat and dog. Now with a good vocabulary, he is able to tell which one is, clearly he is able to say this one is cat and this one is dog with clear vocabulary. Right? So what is happening as time progresses, as he gains more experience, he is able to improve. That person has improvised with through experience. If the same kind of behavior is applicable to a machine, that is called machine learning. Okay, fine. Because in this 2.5 years duration, that kid has, he might have seen so many number of cats and dogs, and with that experience he is able to distinguish which one is cat and dog. But how? So that is nothing but experience. Looking in a day-to-day life, looking at cats and dogs has become a part for him, and naturally he is able to sense which one is cat and which one is dog. But how a machine can do that? From where the machine will get this, that is the experience, through data. So this is the place where data science comes into picture. Data science uses mathematics, statistics, probability, linear algebra, such kind of mathematical techniques, and it gives the learning experience to the machine. Okay, so at this juncture, that is the role of data science. A data scientist will make use of machine learning algorithms to build artificial intelligence systems. Okay, right. Similarly, what is deep learning? Deep learning is also a kind of machine learning approach, but the approach is different. Deep learning algorithm uses another approach to build uh, your AI systems, and that approach is artificial neural networks. This is basically a separate way of implementing AI systems, building AI systems. So deep learning is also considered as a part of machine learning. So basically in machine learning, we have two approaches. One is statistical based approaches, and other one is a neural network based approach. The neural network based approach is considered as a deep learning. So if you look at this diagram, you will understand, you will get a idea of what is AI and what is machine learning and what is deep learning. AI is broader in perspective. Artificial intelligence is very broad, and in that machine learning is a part, or machine learning is used to implement AI system. Similarly, deep learning uses a just one specific portion or one specific a way of approach to solve artificial intelligence problems, AI problems. So this is the Venn diagram of AI and ML. And if you look at the machine learning paradigm, in that we have the machine learning approach, which is totally different from classical programming approach. Okay, so basically the classical programming approach, that is in the programs like C programming, Java programming, C hash, in such kind of programs, we have to give the data and rules to the program, then you will get the answers from the program, right? But in machine learning, you have to give the data as well as the answers from the past experiences. You have to give the data and the algorithm figures out the rules by itself. That is the beauty of machine learning. No need to give even a single rule to it. It is able to frame the rule by itself. So to understand that, how it happens, to understand that, you have to take up the algorithms and you have to study. However, the machine learning approach is different from classical programming approach. So this is a very interesting aspect of artificial intelligence. So basically the programming. It is a very interesting aspect of programming. That is, no need to give a rule. The system itself figures out the rule based on the data as well as the answers that are given to you. So here we have so many things that you have to learn, like labeled data and unlabeled data. So in labeled data comes with data and answers, and how it will be used in supervised machine learning. All those aspects are there to learn.